Welcome to Unreal Gems. In this video, we are going to take a look at how we can create levels of detail for static meshes. Roll intro. Okay, so we are going to start in Maya instead of Unreal because this time we are going to first learn how to simplify and create LODs in external software, not in Unreal. So we have a 1 million polygon mesh with approximately the same number of vertices, and we are going to be able to generate LODs for this mesh in Maya. But first of all, we may have problems with non-manifold geometry. So the first thing that we are going to need to do is clean up the mesh. That's what I am doing right now. Once it's clean, we can go ahead and create the LODs. We would have two ways of creating LODs. First of all, we are going to go to the level of detail section and we could generate the LOD meshes. Another way is creating LOD groups manually and manually decimating the meshes. But since this is not a LOD tutorial, let's go ahead and generate automatically the LODs. We are going to create 3 LODs. The reduction method is going to be a percentage of triangles or vertices. And let's create 3 LODs at 33%, 60%, and 88% simplification. And with that, we are going to generate the LODs. This is going to take a while. So let's go ahead and accelerate the process, speed it up in post, because as you can see, it's quite a big mesh. Okay, we are done. And now we can go ahead and take a look at the LODs. You can see that we have LOD 0, so the original mesh, LOD 1, LOD 2, and LOD 3. So one thing that may be problematic is keeping the LOD meshes names the same, because when we import everything together in Unreal, it's going to complain about the name of the meshes being the same and having a name clash. It will still import the LODs, but it can be important if we don't want warnings to change the names. Once we have the LODs ready, we can go ahead and utilize the game exporter to export an FBX. We can go ahead and disable smoothing groups and tangents and binormals because we are going to triangulate and the FBX exporter is not supporting that. We can change to FBX 2020. Select a export folder, select a file name, in this case the Apollo 11, and once we have that, we can go ahead and export the mesh with the LODs as an FBX. We can click OK, and once we have this, we are ready to jump to Unreal. So we are back in Unreal. You can see that I have the original Apollo mesh without LODs. If we take a closer look, we can see that this is quite a heavy mesh. You can see that it has almost 1 million triangles and vertices. So with no LODs, this is going to be troublesome for performance for sure. As you can see in the LOD picker, if I click, nothing happens. So that means that there are no LODs. So I have 2 folders just for organization's sake, one with the no LOD mesh, and we are going to import in the LOD folder the mesh with the LODs. We can drag and drop the Apollo 11 FBX in set folder, and we are going to need to switch on some options. Remember that the advanced tab is not unfolded by default, so under the mesh section, we need to unfold the advanced section. In there, you're going to find the import mesh LODs option. You can go ahead and click on it, activate it, and then it's just a matter of hitting import all, and it should import every LOD that we created outside Unreal, in this case in Maya. This process can take a while with big meshes like this one, so I'm also gonna accelerate it. You can see that everything has imported correctly. So with that, we can go ahead and open up the Apollo mesh and let's take a look at the LODs. Let's see if they have imported correctly. If we choose the LOD picker, you can see that whenever we click on it, you can see the LODs that we created before. The first LOD, LOD0, is going to be the original mesh. You can see that LOD1 has less vertices, LOD2 even less, and LOD3 even less. You can see that this has several problems because we were too aggressive simplifying triangles and vertices, and we didn't look at the options in depth in Maya because this is not a Maya tutorial. So you can see that right now we could have problems. If we see this LOD switch close to camera, we are going to see the change in quality, and we do not want that. So we will have to deal with that later. The auto LODs are calculated by the engine and will switch accordingly depending on the distance to camera. So we can go ahead and resize the Apollo to fit our scene, and we can go ahead and move it also to place it correctly on the scene. Right now, this is the Apollo with the LODs, and we are going to see how the LODs behave in our level. Let's go ahead and close the content browser so we can see better. And now we can go ahead and take a closer look at the LODs in our Apollo. If we go down to the details in the LOD section, we can see the forced LOD model. If we change that number, 0 is the auto LOD, 1 is the LOD0, 2 is the LOD1, 3 is the LOD2, and 4 will be the LOD3. So if we now change to 4, you are going to see that we have the degraded LOD that has several problems. So you can see that if it changes, we are going to notice it if the camera is closer. In automatic, as we get back, you can see that the LODs change. It is quite difficult to see it just with our naked eye, so let's go ahead and use a level of detail coloration rendering mode so we can see the LOD switches better. You can see that the first ones are not appreciable. As we get back, the color changes to red, so LOD1, LOD2 is green, and LOD3 is blue. Now you can see perfectly when LODs are switching, but if you do it correctly, with the lead mode, you should not see the change. So in this case, you can see that the third LOD is clearly a problem, but we will see how we can deal with that, being able to change when the LOD is going to switch. So gray is of course the native mesh without LOD changes. Okay, so let's now go ahead and deal with the problem of the third LOD, which is not precise enough. We would have two ways of dealing with this problem, either changing LOD level far away so you cannot see the problems, or, as we are going to do now, importing another mesh with a simplified mesh, another FBX with the simplified mesh but without the visual defects. So in this case, we are only going to re-import one LOD. In this case, LOD number 3, which is the one that has the problem. You can see that LOD 1, 2, and 3 are simplifying, and just if it's not clear before, let's go ahead and take a look at how we can switch LOD levels with the level of detail coloration, just in case you didn't believe me before. If we now select, the gray is LOD0, red LOD1, green LOD2, and blue LOD3. Okay, so let's go back to LIT and let's deal with the problem in LOD3. If we want to re-import just one level of detail, we can go ahead and choose in the LOD import, re-import the LOD level that we have problems with. I can navigate to the Apollo Custom LOD FBX, which has, as I mentioned before, a simplified mesh, but without the simplification problems. You can see that it's still going to be lighter than LOD2, but this time is going to be visually more pleasing. So you can notice the change less. So right now you can see that the LOD3 has been modified and we are ready to switch LODs, but in a better way. You can see that LOD0 again has the most vertices and triangles, and you can see that triangles went down a lot from 700k to 96k. So you can see that it's quite a reduction, but we have a better visual representation than before. Little more polygons, but not as noticeable the drop in quality. There is another trick that you can do, import a new LOD level on its own. I'm not going to do it because it's quite a neat trick. You can import an empty mesh and it's going to be a way of doing distance culling. So when the object is really far away, you are going to switch it for an empty mesh. So it's going to save on performance. It's not the orthodox way of doing this, but it is a cool trick that you can do. Switching instead of to a simplified mesh to an empty mesh. So once we know how to import external LODs, we may be wondering if we can create them in Unreal. You can see that now I have a mesh without LODs, and we are going to use the automatic LOD generation system in Unreal Engine. You can see the LOD groups that we didn't know what were before, but we are going to find out now. Let's go ahead and select the correct group. Be careful with foliage because it creates no LODs. So if you select foliage, it's going to not create LODs. This is due to problems sometimes with the foliage and the static baking settings. But you can go ahead and create, for example, the high detail profile, so the LOD group, and you are going to see that it will create LODs. You may be wondering what settings these groups have. We are going to take a look at that later. Now we can click on yes, and it's going to start creating the LODs. For big meshes like these ones, it can take a while, so I'm going to accelerate it. You can see that it has now finished. And if we take a look at the LODs that it has created, it will create 6 LODs in the high detail mode. So from 0 to 5. You can see that we can go ahead and use the LOD picker to switch between them. We start with LOD in automatic, LOD 0, original mesh, LOD 1, simplified, we go down to 300k, LOD 2, 180k, LOD 3, 90k, LOD 4 is going to be 45k, and LOD 5, you can see that it goes down to 22k and 40k. This one we start to get problems, so I mean with the big reduction in geometry, this can be expected. We cannot do magic, but you can see that the problems for the simplification process are not too bad. We are with less polygons than before, and we have way better visual quality. That's something that I have observed. If you use the Unreal Engine auto generation, it's slower than Maya, but the quality is way better. At least with the settings that we used in Maya. If we probably change the settings, it could be better. We could also customize a certain LOD, selecting it and going to the reduction settings. We can recalculate it, switching, for example, the percent triangles. We can also remove the LOD, and we can choose the base LOD that we want to reduce to create it. We can switch from percent triangles to vertices or to any of those. And you can see that we have several options to recalculate again the selected LOD. And if we, for example, saw problems like before with the third LOD, we could go ahead and recalculate it again and be less greedy with the percent triangles or whatever. So you have full control. Again, with LOD groups, you are going to see that we can switch from one to another and they will have different settings to create the LODs. And we are going to see right now what those settings are and what each one of them does. So if we go to our project and our config files, we can find the default engine.ini. In that file, we are going to be able to create our own LOD groups. So if we take a look at the base engine ini, which is located in the engine config folder, so there we will have under static mesh LOD settings the already existing level of detail groups. So here you can see what parameters they have set, and you can use these as templates to create the new LOD groups. That's what I have done right here, which is I added to the default engine ini the static mesh LOD settings section, and then I created a new custom LOD. You need to rename the variable first of all. So instead of whatever other name it has, you can choose one yourself. Then you are going to be able to set the number of LODs. So in this case, we have chosen 3 LODs. Next, we have the max num streamed LODs and the V support LOD streaming. This has to do with streaming and it's quite advanced. So let's skip over it because the video is already going long. You have also LOD percent triangles, which is set to 50. So it removes 50% of the triangles from the earlier LOD. So for example, the first LOD will be 50% less triangles. The second one will be 50% of 50% less triangles. And last but not least, you have the pixel error in this LOD group, which is just the error in pixels that you get when you compute the new LODs. So if it's, for example, less, it's better. If it's bigger, it's going to be worse. So the tolerance for the pixel error will be higher. Next, you have the localization parameters, which is the key and the name of the LOD group. And last but not least, we have the settings, and I have added this table so that we can go over the different settings that we have not covered here. So you have num LODs, we already talked about that. Light map resolution, not important. LOD percent triangles, we already talked about that. Pixel error, already talked. Max deviation, you can set a maximum distance to the surface of an LOD that it can deviate from the original. So it's another parameter that is going to affect quality. Then you have welding threshold. Again, similar to unite some vertices, you need a threshold. Here is where you set it. The hard angle threshold for the normals. So it's just, again, another threshold that you can choose and that you are going to be able to merge normals. Next, we have silhouette importance, texture importance, and shading importance. Those names are already pretty indicative of what they do, but what is not indicative is the numbers that you have to set. So 0 for the lowest priority and 5 for the highest. Usually you can use 4 to prioritize some of them. For example, if I want the silhouette to be important, I will use a 4. Remember that for this to work, we need to change the default engine.ini in the project config folder. So with this, we have everything we need to create our own LOD groups. So after restarting the engine, if we go to the mesh editor, we are going to be able to see in the LOD group the custom LOD that we can choose, that we have created, and we can now use to create our custom LODs. So you can see it right there. You just need to choose it and it will get the settings that you have implemented in your custom LOD group. So as you can see, it is quite easy. You just need to modify a couple of files and that's pretty much it. Remember to just restart the engine and you will be good to go. Another typical problem that you can face when creating new LODs, like for example in this case LOD 5, which is quite aggressive, is that some materials may disappear because no tries or no vertices depend on them. And in that case, Unreal may decide wrongly that you want to get rid of some material. So if you are missing a material, it's just a matter of going to the remaining slots and just changing easily with the material slot the material that Unreal has chosen, and you will be good to go. From that point on, it will be set to whatever you want and that will be it. So this is quite a common occurrence, so watch out for it, because if the material is small or something like that, when you simplify the mesh, it can go away. Next, another typical thing that we can do is choosing the minimum LOD. So for example, right now we are using automatic LODs, or you can see the LOD 0. And with that LOD, you are going to see that it is quite dense, and for some platforms, it may not be the optimal setting. So we can choose the minimum LOD and set it to the LOD that we want. For example, in this case, 4. And as you change that, you can see that it will change. But for PC, we want usually to leave it at 0 and take advantage of the full resolution of the mesh. But we can override per platform. So we can choose the desktop override and leave it at 0, and then choose a mobile override and change it to, for example, another number, like for example in this case 3. With that, when we play the game on mobile, you can see that it will choose as minimum the LOD number 3, and you are going to see that it is going to improve in terms of performance. You can also see that there is another option that mentions LOD for collision. So in this case, this option has to do with how we calculate complex collisions. Remember this because if it's simple, it will not matter. But when we are using complex collisions, so for example, in this case, we would be using level of detail 0, that would be really bad if you have a lot of traces or a lot of things that are going to use that LOD for collision. In that case, you will see a noticeable slowdown, and it's because the mesh is too dense, a lot of polygons to trace, and you would be better off using simple collision and its rigid bodies, or simplified LOD for collision instead of 0, but using 5 or 4 or whatever you feel is enough. That's more or less it. You can find an LOD that matches pretty well your mesh, but is way less dense, so everything performance-wise would be way better. So next, we need to deal with the screen size. So what does this mean? So in terms of changing LODs, when we are in automatic LOD selection, you need to define when are they going to be changed. If we activate the custom option, you're going to see every setting together. We can tick and untick boxes to make them pop up or pop out, and this is going to be a quality of life thing, so we don't have to click everywhere. You can see that the screen size is grayed out, so we need to deal with that first so we can change it, and that is going to be what allows us to customize when the LODs pop up and pop back out. So how do we do that? Well, it's pretty easy. If we go down to LOD settings, you're going to see that there is an auto-compute LOD distances checkbox. You can untick it. And once you do that, you are going to see that the screen size is not grayed out and you can change it. Remember that the LOD calculation, the automatic calculation in Unreal, is optimized for this. So changing it is quite an advanced thing and you need to be careful. If you are in doubt, just leave it as is and you will avoid problems. So if you don't do it, you can use the technique that I will use now, that I like better than doing it in the mesh editor. You can open it up as a window and put it side by side with the level so that you can see the changes in real time. Let's switch view modes so we can see that LODs popping, and now we are able to see in real time as we change settings in the mesh editor how the LODs change. Okay, so let's say that we wanted to have the LOD 0 up until now. We can choose a screen size to achieve that. How can we do it? Well, it is quite easy. We can use the numbers on the right to represent certain sizes on a screen. So for example, I can say that the object should be higher than a 75% of the screen. So the size of the object should have more than 75% on a screen. Let's say 0.9, so a 90% because we want it to be when it is quite close. And now let's say when we want the LOD1 to pop up. Instead of 90%, let's say that we wanted to pop it up in 75% or 80%. So we are going to see the LOD switch when we say. So you can see that right now it's still in the gray LOD, so LOD 0. If we go back, we are going to see it switch to LOD 1. So this is what we want, quite aggressive switches, because these meshes still have a lot of density, a lot of geometry, so it is going to be okay. Let's now say it to pop LOD2 at 75% instead of 85%, and you can see that it pops quite quickly, which is what we want, because as I say, you are not going to see visual change in the mesh. So let's pop the LOD3 right now, and let's go ahead and say at 0.6. In this case, you can see how it pops up to blue. If you are wondering how to know the screen sizes, with the mesh editor, you can see the current screen size and you can guesstimate which ones are the proper ones. So LOD4 at 0.45, so 45% of the screen, and then LOD5, so the sixth LOD at 0.25, which is going to be purple. And you can see that it is quite okay, but with the LOD coloration, this should not be the last step, because it is quite difficult to see if the mesh has changes visually. So let's disable the mesh LOD coloration mode and let's go to lit, and now let's test it out and see how the Apollo looks when we go back and if we can see changes in the LODs. You cannot see anything at all. Maybe in that last one you could see a pop in the details near the handles, but you can see that it is quite difficult to see and you have to be paying a lot of attention. So just remember to check with the lit mode that the changes are quite difficult to appreciate by the player. Okay, so once we are satisfied with this, there is another thing that we could do. Because remember the minimum LOD in use when we were talking about different platforms, we could switch and we could use one in mobile and one in desktop. Well, we can do the same for the LOD screen sizes. So we could use one for desktop and one for mobile. Obviously, we are going to be way more aggressive with mobile, and this is obviously going to account for the minimum LOD also. So if we set in mobile a minimum LOD of 3, well, we don't need to set screen sizes. I'm gonna do it anyway just to be clean, but remember that it also accounts for minimum LODs, so the engine will not allow LODs higher than what we established before. So you can see that I am being more aggressive with the mobile version, so I'm saying that LODs that have less geometry pop up earlier than in the desktop versions. So you can see that for mobile I use higher numbers so that different LODs pop up when things are bigger on a screen before, so that we don't use too much geometry in any case. We could do this for all of the rest of the LODs, but you get the picture. You just have to add an override and that's pretty much it. So after all of this, I wanted to show you that this is not like something that I do for fun, but I do it for the performance. If now I start duplicating the Apollo that does not have LODs, you are going to see, if I turn on the FPS, that as soon as I start duplicating it, no matter how close or how far away the mesh is, it's going to start dropping frames. Take a look, right now we are at 23 FPS, 20, and as I start duplicating more, we are going down. So we need a solution, because this is clearly not the way. We cannot spam dense meshes all over the place without regards for performance. So we are back up again to 25 FPS, 30 FPS, and we are going to see what happens when we duplicate the Apollo with the LODs. You can see that as soon as I start moving them, frame rate stays the same. If I go ahead and duplicate it more, you can see that we are still at 25 FPS. If I go ahead and do it even more, you can see that we are still at 25 FPS. This is not magic. This is LODs working and doing their job. Why? Because we have a mesh with 1 million triangles. If we start spamming the mesh all over the place, we are going to be draw call limited and geometry limited. But if instead we duplicate the mesh with the LODs, this is not going to be the case, because as I get the mesh far away, the different LODs are going to pop up and they have less geometry. So with my students, this is one of the highest causes of problems with performance, because you can have trees or other meshes far away, lots of them, like 200 trees or whatever, and they are using the full resolution of the mesh. Well, as you can see, levels of detail in Unreal Engine are quite easy to use. You can auto-generate them, import them, and the system works automatically when switching levels of detail. If you have liked this video, go ahead, like and subscribe. We'll see each other in the next videos in the series, where we will dive deep in skeletal mesh levels of detail.